Okay, so to kind of explain how the adaptive collision works, we've got this theoretical sort of diagram that illustrates a typical rigid body collision using adaptive collisions on. So we already talked about how the sub-steps basically represents how many times we sample the rigid bodies per frame. And the adaptive collision sort of works hand in hand with that. So if we look here from T0 to T1, we can basically see this as representing one sub-step. So what essentially happens is we take a snapshot of two objects when they interpenetrate. So basically as soon as two objects interpenetrate, this sort of defines a collision event, and the adaptive collision that can then kick in. So what happens is initially we compute this value d, which basically determines the distance of interpenetration between the two. So let's say initially we compute the d value, and that's equal to 0.1. So that value is compared to an internal threshold we set for the d value. So let's say internally, just for the sake of the example, that the d threshold is set to 0.001. So we compare this value with the threshold, and since it's over, what we do is we rewind and go back in time half a time step and recompute the d value. So at this point, basically you can see the two rigid body objects as rewinding a bit and potentially interpenetrating less because we're going to an earlier point in the collision. So at this point we see that the d is equal to 0.05. So again, if we compare it to the threshold, it's still above. So we need to go a bit further back in time. So we go back another half time step. So we're basically subdividing, going back here, and we compute the new d value. So at this point, perhaps we're right near the beginning of the collision, and the d value is very low, and it actually is below the threshold, the d threshold that we have set internally. So at that point, we're happy because we've basically met our criteria, and we're below the threshold. So now we can start going through the collision and computing it and trying to basically model the collision as accurately as possible using this adaptive technique. So we can double the time step then. We double it, and then we go ahead in time in the collision, and then we see that the d value again is above the threshold because we're too far in. So we rewind again half a time step, so we go down to here, and then this d value, let's just say it's below the threshold, so we're happy here. So then we can double that, and again, if we have another successful criteria match where the d value is lower than the threshold, we can keep doubling it and therefore slowly go through the collision and compute it. So each time we subdivide, basically that represents the adaptive level. So, you know, at the first subdivision we're at 1, second 2, third 3. So basically if you set your subdivision to level 3, your adaptive collision to level 3, what you're going to do is get 2 to the power of 3 level of subdivision. So that would be 2 times 2 times 2 is 8. 8 times 4, because you have by default 4 sub-steps, is 32. So you'd have a maximum of 32 samples being computed if you set the level to 3, and that's per frame. By default, the adaptive collision is set to 8. So what that means is you have 2 to the power of 8 times 4. So that gives you a maximum of 1024 samples per frame, which is quite high when you think of it. You're actually computing over 1,000 samples per frame for the collision. So that's something to keep in mind when you're actually adjusting these values. So theoretically, that's just a rough look at how we actually do the adaptive collisions, and you can basically see it as like progressively refining down to compute, you know, a finer granularity of the collision, and then slowly ramping up to, you know, to resolve the entire collision detail. And that's kind of what adaptive means in every sense. Like even with anti-aliasing, you're progressively subdividing things to get to more levels of detail. And it's no different with the rigid body dynamics. But it's just useful to have that concept in mind so you have an idea of what work's being done. So now let's look at, I guess, more production-oriented examples of how to set the actual adaptive collision and sub-steps.